Okay, 2-4 is all about applications. So it's just a bunch of word problems. I'm using those trig functions, okay? So it's all applications. So we need a couple of definitions. So, angle of elevation. Angle of elevation is an angle measured from the horizontal up. So think about you're standing on the ground and you're looking at a bird or the top of a tree or something like that. An airplane, the sun. Those are all angles of elevation. An angle of depression is an angle measured from the horizontal down. Think about fish or a submarine, or you're standing on top of a mountain looking at, you know, the ground, or you're I don't know, in an airplane looking down, hot air balloon, standing on top of a building, okay? So you're horizontal down. Okay, well, let's look at those two things for just a second. Rewind your brain back to geometry. Hate it when she says that, right? Okay, I promise it's not horrible. If I tell you those two lines are parallel, we'll pretend I can draw really straight lines. So they're parallel, right? And then I'm going to drop in, ooh, big geometry word, a transversal. Ugh, why do you got to do that to us, lady? Well, look at it for a second, right? Here's my horizontal, and I measure up. That guy right there would be an angle of elevation, correct? But what do you remember about parallel lines from geometry? Which one's the same? The one across it on the other side of the transversal, right? The alternate interior angles. So this guy right here is an angle measured from the horizontal down. So this guy right here is an angle of depression. And this angle right here is an angle of elevation. And what do you know about both of those two angles? They're the same. They're called alternate interior angles, yeah? Okay. So what that means is no matter how you draw it, if it ends up being outside of your triangle, flip it over. Does that make sense? So the angle of elevation and an angle of depression are really the same angle. Okay? Keep that in mind. I'll put that up there so we can look at it if we need to. Okay, the last one that we have is called the bearing of a line. This is something that airplanes use, ships use, your compass uses it, all those sort of things. It's called the bearing of a line. And it's an angle measured clockwise from north. Let me show you. Yes, it's on your phone. I will show you my phone. Just have to find it. Okay. Well, true north, right there. Wow, I didn't quite get there. Come back, buddy. There, right there. You're being a little wonkadoodle. That's okay. Okay? I don't think that's right. That feels easty to me, but that's okay, whatever. So, as you notice, the whole way, when you go around it, let me set it flat. When you go around it, what do you notice about east? 90. What about south? 180. What about west? 270, right? And then all the way back around. So it's 360 degrees with north being 0. All right, so I'm going to draw you a compass rose, if you will. North is 0 degrees. Bless you. East is 90 degrees. South is 180 degrees. And the west is 270 degrees. So they'll say something like, go on a bearing of 360 degrees. Or, no, they're not going to say that because that's 0. Go on a bearing of 232 degrees. Well, that means you're coming down this way. You're headed southwest. Does that make sense? Go on a bearing of 85 degrees. You're headed northeast. Does that make sense? Okay. We're going to use that here in just a second. Number 1. Let's look at number 1 and let's go ahead and just work through these word problems together. So it says the two equal sides of an isosceles triangle are each 24 feet. If the base angles equal 52 degrees, find the length of the base and the altitude. All right, first of all, we have got an isosceles triangle. What's that mean? Two of the sides are the same length, right? Okay, so here we go. They're both 24 feet. The base angles are 52 degrees. It says find the altitude. So I'm going to drop it in altitude. Remember, an altitude makes a right angle. And the length of the base. Let's call this guy H for his altitude or his height. Let's find that first. What do you want to do in order to find that? Maybe I'll cover up one of the triangles. Here's 52. Perfect. Sine of 52. Opposite, which would be H. Hypotenuse would be 24. Solving for H, I'm going to multiply by 24. So 24 times the sine of 52, 18.9. Now, if you leave your answer like that, I'm not a cranky lady. But how many sig figs are in my problem? 2. So technically it should be 19 feet, right? What do you think about the base, though? China.
It's still final length of the right triangle.
Yeah. Perfect. So what she's saying is let's find just half of the base right there and then double it because it's going to be the same for both of them. So I'm going to call it x. Okay, so what trig function do you want to use now? Perfect. Cosine of 52, because now I want the adjacent, which is x, over hypotenuse, which is 24. So 14.78. And then I'm going to double it because I have two of those, so 29.6, which means my base is 30 feet when I go to sig figs. I guess 30.0. 30 decimal point, but 30. Griffin, you have a look on your face. You're okay? Okay. I would say the trickiest parts of these is drawing the picture. So if you get stuck, let me know, okay?
So, next you, is 124 squared plus 24 squared equals the base of 2,000?
We don't know that this is a right angle up here.
Okay.
So we can't do the Pythagorean theorem. Then you get to also laugh at me for the way I draw pictures. So here we go. Number 2 says if a 75-foot flagpole casts a shadow 43 feet long to the nearest 10 minutes, what's the angle of elevation of the sun from the tip of the shadow? Okay, so here we go. Here's my flagpole. My flagpole is 75 feet long, 75 feet tall. And his shadow on the ground is 43 feet. And we're going to assume that we put our flagpole perpendicular to the ground. So he's a straight flagpole. And if I'm standing here at the tip of my shadow and I look up at the sun, what's my angle of elevation? So I'm standing right here. We're going to ignore how tall I am. My eyeball is sitting on the ground and I'm looking up at the sun. Okay? Here you go, Gift. All right, so which trig function do you want? Or should we use? You can go sit out in the pocket. Tangent. Here's my angle, opposite over adjacent. So the tangent of theta is equal to opposite 75 over 43. Do I have an angle? No, I need an angle. So in my calculator, arctangent, 75 divided by 43. It said to the nearest 10 minutes though, so I'm going to go and convert this guy to degrees, minutes, seconds. Degrees. This one's nice and easy. 10 degrees. 10 minutes, excuse me. Like I said, the trickiest part is drawing the picture. So if you get stuck, let me know. Or if even on your test and you're like, did I draw it correctly? I'll be glad to tell you yes or no. Shayna.
So by asking to the nearest 10 minutes, that means we just round it to the closest.
Right, so yes. So 10, 20, 30, yeah. All right, number 3 says, a man climbs 213 meters up the side of a pyramid and finds the angle of depression to his starting point is 52.6 degrees. How high off the ground is he? Okay, so here's his pyramid. He climbed the pyramid. I am the champion, he says. He's standing on top of his pyramid. He looks down at the bottom. Oh, and he climbed 213 meters up the side. He looks down at the bottom, and that's 52.6 degrees. Okay, so this angle right here is 52.6. Where else is there a 52.6? The other side, the opposite side, or the inside of the bottom of the pyramid, right? So this guy right here is also 52.6 degrees. We want to know how high off the ground he is. Okay, which trig function do I want to use? Sine. I have opposite and hypotenuse, so the sine of 52.6 is equal to opposite, which is x, over 213. How high off the ground is he? 169 meters. Okay, you doing okay? We got 3 left. Okay, number 4 says, on page 95, there's a topographic map. Suppose Stacy and Amy are climbing Bishop's Peak. Stacy is at position S and Amy is at position A. Find the angle of elevation from Amy to Stacy. Okay, so here's your picture in your book. This is a topographic map. Have you seen these before? It tells you the elevation, right? So here here's my scale, and it says 1 inch is 1,600 feet. Meaning if I look down at it like a bird and I measured, as the crow flies, they say, that would be 1,600 feet that they're apart. Does that make sense if it were an inch? Then it also tells me the contour interval. The contour interval means every time I see one of these lines, it goes up 40 feet this way. Okay? So as I look at these guys right here, if I measured them, see my scale's there at an inch, and then I measure these 2 guys here. I'm not convinced my ruler's accurate, but it looks like 3/8 of an inch. 1, 2, yeah. Three-eighths of an inch apart. Okay, so they're 3/8 of an inch apart. How many rings are there between the 2 of them? Well, it goes there. There would be 40 feet, 80 feet, 120 feet apart. Would you agree with that? Meaning Stacy is 120 feet higher in elevation than Amy. Okay, so let's do some good math here. First of all, on the map, they're 3/8 of an inch apart. And 3 rings, if you will. 3 contours. So think about them. They're climbing this mountain here. Or this peak, excuse me, Bishop's Peak. And we decided that Amy is further away from the top than Stacy is. So at 3 contours, that means that they are 120 feet apart like that. Does that make sense? Height-wise. And on my map, if they're 3/8 of an inch apart, Well, 3/8, a whole inch would be 1,600 feet. If I just looked down them like I was flying over them. 3/8 times 1,600. They're 600 feet apart. Just looking down on them as if I were a bird. Does that make sense? So then it says, find the angle of elevation from Amy to Stacy. Which trig function do I want to use? Tangent. So the tangent of theta is equal to opposite 120 over adjacent, which is 600. Do I have an angle? Nope, that's what I need. This one didn't really have a whole lot of significant digits in it, so we'll just say 11.3 degrees. Okay, are you okay with those ones? Questions before we do the last two, because the last two are about bearing. The bearing in your book is different than how the real world does bearing. So, when we talk about bearing, I've changed it so that it matches what the real world does, okay? So if you were on a ship or an airplane or anything like that, or you used your compass, then it would be 360 degrees with north being 0, okay? I think that's a little bit better so that it's more useful for you. When you go to pre-calc, this is how they'll talk about bearing as well, okay? That being said, I didn't assign you any bearing problems out of the book, but there's a worksheet on the next page that's part of your homework as well, okay? So if you get stuck on bearing, what I'm trying to tell you is don't go read your book on the bearing problems, because I've changed it. Does that make sense? Okay. So, number 5 says, San Luis Obispo, California is 12 miles due north of Grover Beach. If Arroyo Grande is 4.6 miles due east of Grover Beach, what's the bearing of San Luis Obispo from Arroyo Grande? I think these are all, yeah, they're all in California. All right, so here we go. Let's draw a little picture. So the first thing it tells us is San Luis Obispo is 12 miles due north of Grover Beach. Okay, so here I've got Grover Beach. And if I go 12 miles north, I get to a place called San Luis Obispo. Then it tells me that Arroyo Grande is 4.6 miles due east of Grover Beach. Okay, so if I'm standing here at Grover Beach, due east is 90 degrees this way. And if I go 4.6 miles, I get to, oh, that's not a 6, lady, that's a 2. 4.6, I get to Arroyo Grande. Okay, then it says, what is the bearing of San Luis Obispo from Arroyo Grande? The trick there is where I'm standing, from Arroyo Grande. So if I'm standing here at Arroyo Grande, I need to know what bearing to go to get to San Luis Obispo. So I'm going to draw in a north. Okay. Well, to get there, I have to go the whole way around clockwise to get to that guy. So how many degrees is it to get all the way over here if I were to go to due west to if I were to go to Grover Beach? 270, right? But then I'd have to go a little bit further so that I could head northwest to get to San Luis Obispo. Does that make sense? So I need this angle inside of my triangle. Can I find that? How? Tangent. Perfect. The tangent of theta is equal to opposite 12 over 4.6. Arctangent 12 divided by 4.6. So if I start and I aim due north and I go all the way around to 270, I'll get to Grover Beach, but I gotta go 270 plus that 69 degrees. So what's gonna be my bearing? Perfect. Questions on that? The trick to some of these is to, every time that you stop, draw a new compass rose. Okay? China. You're good? Okay.
So are we always facing north?
Always start facing north, because that's 0. So I would say yes. Does that help? Okay, so here we got last one, our boat. A boat travels on a course of bearing 052, so 52 degrees. Think about that for a second. Which direction are you heading? Northeast-ish, right? For a distance of 238 miles. It stops, and at that point, how many miles north and how many miles east has the boat traveled? So it's gone 238 miles northeast. Here's my boat. He started out here. Here's my north. He went 52 degrees this way. There's 238 miles. That guy right there is 52 degrees. North and east make right angles. So how far north and how far east have I traveled? He went northeast, but if I were to go get him by a straight line, you know, if I had to go north first and then east, how would I get to him? Does that make sense? Okay, so here I go. There's my angle. I have to do two things. Let's figure out the north one first. Cosine of 52 equals opposite, sorry, adjacent, excuse me, x over 238. Okay, so 238 times the cosine of 52. 146.5, and if we do 6 then it would be 147 miles north. Okay, how about east? Equals y over 238. 188.5. So 187.5, excuse me. So he's gone east 188 miles and north 147 miles. Okay, so your homework from this section, 14 through 26 even. So there's not very many on page 100, but then you need to do your worksheet. Okay? There are 1, 2, 3, 4, 5 bearing problems, and the one at the top you're just drawing it. What would that look like? Does that make sense? So essentially you have 3 things to do, 2 out of the book and your worksheet. Okie dokie. Thomas.
When you're drawing the bearings like the worksheet, do you have to both on a protractor or check?
No, just slap them in the right place. Does that make sense? Yeah, don't worry about a protractor. Good question.